Hi, today's lesson is about relation between fractions and decimals and about rational and irrational numbers, which goes with your day 3 assignment. Rational numbers are numbers that can be written as a quotient of two integers where the denominator is not 0. Actually, to make it quite simple, any number that can be written as a fraction is a rational number. If you take a number and write it as in a decimal form, then the decimal form of that number has to either end or repeat. So if you take this fraction, 1/2, and you change it to a decimal, it will be 0.5, which is terminating decimal. It will stop. 8/99 would be repeating decimal. That's a rational number as well. Every whole number is a rational number, such as 7 and 155. And again, terminating decimal and repeating decimal, they are also rational numbers. Now let's talk about more closely about repeating and terminating decimal. So terminating decimal is the decimal where you start division, you are doing division, and then at some point of time there is no remainder. So the division stops. So 0.5, 0.125, 3.24, all of those would be examples of terminating decimal. Any whole number is also a terminating decimal. Now repeating decimals are decimals where one or more digits keeps repeating, and such decimal actually goes forever. So example would be 0.3333, and these points are at the end tell us that that repetition goes forever. Oh, this is another example. Now, how can we write this shorter? So if you have 0.333 repeating in shorter version, you can actually write it 0.3 and then just the repeating bar above that first digit that starts repeating. So from 0.73 repeating, we would put 0.73 and put the repeating bar above both digits. What we have to be careful though here is how far do we put that repeating digits? Because if I write this as 0.737 and I put repeating above that, this number is quite different from that one. This one would mean that 737 repeats, so it would be 737, 737, and so on and so forth, which is not the same as that number that we have there. So you just need to be careful. Now, when we look at that, then the question is what's irrational? Because we said rational numbers can be written as fractions, and in decimal form, they either stop or go forever with repetition. So, what are the irrational numbers? Irrational numbers are numbers that actually go forever without repetition. So, one example of irrational number is pi. Because you know that pi, even though we use 3.14, that's just the approximation. Pi goes forever without repetition. Such other examples are square roots of numbers that are not perfect squares. So what are we talking about here? You see square root of 2. 2 is not a perfect square, then the square root of 2 has to be irrational number. Square root of 3 as well. Now square root of 4. 4 is a perfect square. You get it by multiplying 2 by 2. So because 4 is a perfect square, square root of it is a whole number, which is 2. So that one is rational. But square root of 5 is irrational. Or square root of 15 is irrational number. Or square root of 103, where the square root of 100 is rational number. The last thing we need to look at is how do we graph fractions on a number line. And yes, we can possibly, if we had 1/2 would be very easy to graph here, or 3/4 or something like that. But however, when we have fractions that are not that perfect to graph, we can actually change them to decimal numbers. So here we are. For 8/9, I simply take 8 and divide by 9. Change to a decimal that repeats, obviously goes forever. That's 0.8. I can round it to 0.89. Now on a number line that would be between 0 and 1 because it's a positive. This is 0.5, 0.6, 0.7, 0.8, that's 0.9. 8/9 would be right somewhere there, very close to it. So 8/9 would be somewhere there. -7/4 would be equal to negative, and I take 7 and divide by 4, which will give me 1.75, but it's a negative. So I go from 0 to -1, and then I go to -1/2, 1.5, 1.5, 1.6, 1.7, 1.7.5 would be here. So that's -7/4. -3/7 would be negative, and then 3 divided by 7, which will be 0.428. I can put 0.43 to round it. That would be from 0 into negative direction, 1, 0.1, 0.2, 0.3, 0.4, 0.43 would be somewhere here. So that's -3/7. 8/5, 8 divided by 5. I have 1.6. That would be in positive direction 1, 1.5, that's 1.6. So that should be 8/5. How about if I had the square root of 8? I will find in a calculator how much is the square root of 8, which is 2.828. I can actually round it to 2.83, and then I would find that this is 2.5, so it would have to be 6, 7, 8, and then it would be somewhere here. Or square root of 8. Okay.